Okay, good afternoon everyone. Thank you for giving us the opportunity to present this hot energy topic. As you can see, it's called Unburnable Fossil Fuel in a 2-degree C world. The reason we picked this hot energy topic is that this idea that a significant amount of fossil fuels needs to stay in the ground is definitely picking up traction across governments, of course in academia, but also in the investment community as well. So we thought it was a nice one to reflect and publicize a bit through this hot energy topic. Just to say, the lead author is really Christoph Magladen, and it's based on work that he recently published in Nature. But we also had colleagues from IFRI and EIHP in Zagreb involved in the hot energy topic too. Okay, so firstly, what are unburnable fossil fuels? Well, the first thing to say is that the IPCC suggests that we have a carbon budget between 2011 and 2050, and in order to have a better than evens chance, say 60% chance of avoiding a 2 degrees C temperature rise, we have a budget in the range of 870 to 1200 billion tons of CO2 that's there that can be used, so to speak. However, the unabated combustion of current estimates of fossil fuel reserves are more than 3 times this estimate, and that's what this graph tries to illustrate. So we have our carbon budget here that's outlined in that first bullet point, and then we have these reserves of oil, gas, hard coal and lignite, which are the dark brown parts of the bar chart. And then we also have a lot of resource. The distinction we make between reserves and resources is that reserves tend to be those that are economically recoverable based on current conditions, that have some kind of probability that they could be extracted, whereas resources cover, more of the stuff that we know about, but it's not currently in the picture in terms of what extractive companies are going after. So that's kind of what that graph illustrates. And basically the point is that these dark brown portions of the bar chart are 3 times higher than this carbon budget level. So the logical conclusion is that a lot of these fossil reserves need to remain in the ground, and we term them unburnable. So I suppose the novel thing about the analysis that was done was that it also looked at which of the reserves needed to stay in the ground based on an economically optimal scenario. So it's a model result, but it gives some interesting insights. And it also gave us this kind of distribution based on the resource supply curves that were across the different regions of the world. And so basically we concluded that 80% of current coal, 50% of gas, and 33% of oil should be classified as unburnable, based on this given scenario and the assumptions that we've made about what the global reserve pool looks like. And then, yes, in terms of distribution, we see that the majority of very large coal reserves in China, Russia, and the US need to stay in the ground, 60% of gas reserves in the Middle East, and oil reserves in the Arctic region. Again, this is simply the output of the model based on the economics of extraction of these different resources. The other very interesting conclusion was that in the longer term, CCS technologies didn't appear to play a significant role in terms of changing these numbers drastically. And that's because of the deployment of CCS we assume would only be after 2030 at any great scale. And then by the 2050s, we're looking to really push down on our emissions because our carbon budget is becoming tighter and tighter in the longer term. So that was an interesting conclusion of the analysis. And then because we're a European Union focused consortium and project, we wanted to think about the implications for member states. The modelling suggests that less than 20% of existing oil and gas reserves in Europe was unburnable under this scenario, concentrated in the North Sea. But we still think that, from that you might think that actually there aren't sort of real significant repercussions for Europe, because we don't have the sort of size of a resource base that other parts of the world have. But I think there are some interesting implications of this. One of them is around member states and extractive policies in a 2-degree C world. So if that is the agreement that's on the table, there's a question about whether, extractive policies that want to maximize domestic resource extraction, whether that's incompatible with this economically optimal scenario, particularly under a 2-degree C limit. And also, of course, Europe has a lot of multinationals who are interested in exploiting fossil fuels around the world, so there are implications to the industries within Europe as well. And then, of course, there's the implication of the end-use sector or supply, the transformative sectors that would use large amounts of these so-called fossil fuels, such as coal being used in coal power generation as well. So the brief tries to unpick some of the implications for different member states. And then we have a final section that talks about some implications for the European energy industries and financial markets. Again, there are some interesting implications from this kind of analysis. So within the carbon budget, there are in a 2-degree world again, or an increasingly stringent climate policy regime, there are potential for companies to hold stranded assets. So in a sense, assets are held, but actually they do have liabilities attached to them because of the carbon budget that's in place. So there are implications for investors in terms in these areas around carbon budgets. We did a little bit of work to look at the estimated exposure to firms holding fossil fuel reserves, which is around 5% of total assets for EU pension funds, 4% for EU insurance companies, and 1.4% for EU banks. So not significant to create financial instability in that sense. There are also big questions around the speed of climate policy and the ability of companies to respond. So it might be the case that down the road we know about climate policy, what's happening. Companies will have time to reassess what assets they hold. So that really focuses on the existing story. But then there's this question about new investments and where they should go. And they might also be perceived as more risky in the longer term based on the liabilities I've talked about. And interestingly, within all of this, there are some moral cases being made through the divestment movement about whether universities and other organisations should be holding these types of assets in terms of their investment portfolios. Certainly, the Gates Foundation recently had some publicity around that as well. So I suppose the main conclusion is that there might need to be increasing transparency of these sorts of assets held in the future under this kind of climate policy regime.